Welcome back to our TOC lecture. Today we're going to see how we are going to convert from NFA to DFA. So let's first see what's the difference between NFA and DFA. Apart from lambda transition, we can directly say from the transition diagram that what is NFA and which one is DFA. So the left side of the diagram in NFA, we can see from the state Q1, there is transition for the same symbol A from Q1 to Q1 and Q1 to Q2. If any transition diagram, if there is transition for same symbol more than two transition to different state, then this is definitely NFA. Whereas in DFA, there is only one transition for each input symbol. So this is a basic difference between NFA and DFA. So what is our agenda in the conversion of the NFA to DFA? First thing, if we find any lambda transition, we have to remove. And regarding how you remove, it has been discussed in the previous lecture. Next thing, we have to generate transition table from the NFA and then do some work to get the transition table for the DFA. So there might happen that trap state, that is a phi state, appears while converting NFA to DFA. We have to manage that trap state also. And the last thing in the conversion, that it might happen that during the conversion very unnecessary states are generated. Then in that case we have to minimize the states. So there are actually two types of method are used. That is, one is the partition table and another is the merger table. So this is start with an example. Here in this transition diagram, we can see there is a three state, Q0, Q1 and Q2, where Q1 is a final state and the alphabet set is 0 and 1. So first thing we have to design the table 1. So it is column, each column we have to write the each input symbol, and this first column shows the name of the states and the remaining column shows the transition upon taking each of the input symbol. So we can see from the transition diagram that from Q0 there is a transition for input symbol both itself and Q1. So we write this way in curly brackets, Q0 Q1. Then taking 1, Q0 goes to Q1 only. Again Q1, from Q1 taking 0, it goes to Q2, and taking 1 also it goes to Q2. Q2 taking 1 goes nothing, we can symbolize it at phi, and taking 1, Q2 goes to itself, Q2. The next thing in the table 2, we have to expand this table like this way from Q0. So since there are new set of symbols is generated from this table 1, Q0, we have to also include at the left side here, this side. So in the table 2 we can see that a transition from Q0 to Q0 Q1 for input symbol 0, then Q1 for input symbol 1. So you can see there is entry for this state also. this state also. So for Q0, Q1, we have to see that what are the possible set of states for input 0. So Q0 taking 0 go to Q2, Q0, Q1 from taking 0 go to Q2, and okay, so new state is generated Q0, Q1, Q2, and from Q1, Q0, Q1 taking 1 goes to Q1, Q2. So there are two symbols, two states are generated. So you have to also include this state here like this. So again taking 0, it goes to same thing, 1 0 Q0 Q1 Q2, and taking 1 Q1 Q2. So now it's time for Q1. In Q1 taking 0 go to Q2, and 1 taking 1, it also goes to Q2. For Q1 taking Q2 and Q2, okay, Q0 Q1 for both taking 0 and 1, and then Q2 goes to 5 taking 0, and Q2 goes to Q2 taking 1. So this is all possible states are generated after from table 1 to table 2. So we can rename, we cannot use these long names for further processing, so we have to rename it as ABC. We can use any symbol here. I have used A, B, C, D, E, F like this way. So here another important thing, that in DFA there is only one starting state, and there can be many final states. So in this case we mark the states which is final, whichever include the final state, that is Q1. So this is final state, this is also final state, this is also final state. So that's why Q0 Q1. So we have Q1 also, this is also final states. So we have 4 final states. So A, B, this way we can also we can see that how we have changed the names here. We have also included as file state for 5. Okay. So if I draw the DFA for the corresponding NFA, it looked like this. So this phi is here the trap state. We will see in the final optimization we won't need this trap state. We have to remove this trap state by only just removing the any transition goes to phi. Thank you.